Hi, myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is YACC. YACC is yet another compiler is a computer program for the Unix operating system. It is a look ahead, left to right, rightmost derivation parser generator, that is LALR parser generator. So, this YACC generating LALR parser. The input to YACC is a grammar with C code, that is actions attached to the rules of the grammar. This is the structure of the YACC. YACC is a compiler. For this compiler, we have to give YACC specification file. That file is translate.y. This file name is anything, but the file extension should be y. Y indicates YACC file, specification file, that is given to YACC compiler as input, so that YACC compiler produce a C program, that is y.tab.c. It is a C program. So, YACC specification file is translated to y.tab.c. This y.tab.c is given to C compiler as input, so that C compiler will produce a.out as output, that is object code. Now, this a.out is a YACC program. If you give grammar as input to this a.out will produce output as parse tree or syntax tree. The output of the YACC is parse tree. A YACC source program contains three parts: declaration part, translation rules and supporting rules. These three sections are separated by pair of percentage symbols. These three sections are separated by pair of percentage symbols. The first section has ordinary C declarations, and also we can include some header files. The declaration section always begins with percentage, open curly brace, and end with percentage, closed curly brace. The declaration of grammar tokens also comes in this declaration part. After the first pair of percentage, YACC specification part starts, that is rule section. Here the grammar rules will be given along with the semantic actions. See, for example, E derives E plus E is a rule, grammar rule. This is left hand side LHS non-terminal. This is RHS, body of the production. This LHS is represented by $. This first symbol is represented by $1, second symbol is represented by $2, third symbol is represented by $3. See, head indicates left hand side non-terminal. Right hand side we can have body 1, body 2 or body 2 or body 3 and so on. Like E derives E plus E, one rule, or T derives T star F or F, like that we can have multiple right hand side productions. Then we can write this production rule in the form head colon body 1 corresponding semantic action. This semantic action is written in C language. This symbol indicates R colon body 1 or head derives body 2 or head derives body 3 and so on. So, for every production rule, we need to define corresponding semantic action in C. The semantic action of YACC is a set of C statements. In a semantic action, the symbol $, considered to be attribute value associated with heads non-terminal, that is left hand side non-terminal attribute value is represented by $, while $I is considered as the value associated with the grammar production of the body, that is the value associated with the corresponding symbol on the body. Then in the last part of YACC specification, we should provide a lexical analyzer, that is YYLEX. It is lexical analyzer. Lexical analyzer will take input as a sequence of characters, gives output as a tokens. Sequence of tokens produced by YLEX. This is a function. Then these produced tokens have the tokens name and are associated with its attribute value. The attribute value which is associated with the token will communicate to the parser through the variable called YY YYL value. This is the variable used to communicate these tokens to the parser. This variable YYL value is defined in YACC. This is the example program, YACC program for desk calculator. This part is declaration part. Declaration parts begin with percentage and open curly brace, ending with percentage closed curly brace. So here we have included a header file c-type.h. So that because why we are using c-type.h header file means now we are using this getChar isDigit function. So that to use this isDigit function, you need to include header file c-type.h. Then after that, pair of percentage. This is the beginning of the rule section. Here the two columns are there. Column 1 containing production rules, column 2 containing corresponding actions in C language. See, first rule, line colon expression new line. That means line indicates the line consists of expression. This is expression. Expression is like 2 plus 3 is an expression. End with the new line. Whenever this is encountered in the line expression, the corresponding action is printf %d new line comma $1. $1 indicates this expression that is printed. The value of this expression, whatever associated with the attribute value associated with the expression, that is 5 will be printed. Then second rule, expression derives expression plus t. The expression means E derives E plus t. T derives T star F. E derives E plus T or T. T derives T star F or F, like that. Here E means expression, T means term, F means factor. X derives X colon expression plus term. The corresponding action is the left hand side attribute value, that is $, indicates the attribute value of expression, that is associated with the value of $1. This $1 also representing the value of this expression, $3 representing this value of term. So that $2 is plus. So that we are adding $1 and $3. $1 and $3, that is associated with the $. Then expression derives term. There is no action for this term. Semicolon. For every rule, end with a semicolon. Next, term colon term into factor. The corresponding action $, is equals to $1, $2. As usual, $, representing this term. $1 this term. $3 factor. Like that. Factor is also factor colon open parenthesis expression close parenthesis. See, expression is $2 representing expression 2, $1 is left parenthesis, $3 is right parenthesis. So factor colon left parenthesis expression right parenthesis, that is $, is equals to $2. The value of expression assigned to factor. So factor or factor deriving digit. Digit is a token. So from user input, the YYLEX in the third part will produce the tokens, that is associated with the digit token, whether it is digit or character. In the rule final section, auxiliary rule section, C is declared as integer variable and C is equals to getChar function. GetChar function is used to get the characters from the keyboard. Then we can check the C whether it is digit or character by using isDigit function. If isDigit function is a digit coming to the body, YY value, this is a variable defined in the YACC program. So YYL value is assigned with C minus 0. Here C is user entered value. For example, C is equals to 3. Here 0 indicates we have to subtract 0 from C because the digits are ASCII values of digits starts with 47, 48 and so on. 0 is 47, 1 is 48, like that. If C is entered input, the corresponding value is 50. So 50 minus 47, that is 47. 50 minus 47, that is 3. 3 is assigned to YY value. This is passed to the YACC compiler, so that finally it return the digit that will give the token. Finally, otherwise if it is not digit, directly return C as a character. This is the program for YACC for desk calculator. Thank you.